rate of change. So, what is change? It's something that occurs when properties or characteristics of a part of the environment has been altered. So like in geology, earthquakes cause change. So something must have happened where the plates have shifted with each other and they created a change which causes an earthquake. Volcanoes create change because they change the landscape and so on and so forth. Now, these changes can be instant, like they can happen in a snap, and sometimes some of these changes happen over long periods of time. It may take 100 years, it may take 1,000 years, it might take millions of years for these changes to occur. Okay, so a frame of reference is a time and space that something happens. This is how we study change, is how long it takes in order for something to change. So for example, the moon changes because we observe it in different locations in the sky and in different phases at different times during the month. So you can actually go out at nighttime every night and see what phase the moon is in at that time, and you can figure out how long that takes and how many times it takes over a course of a year, so on and so forth. So now how we figure out how fast something changes is we use the rate of change. The rate of change basically is how much measurable aspect of the environment is changed over a given time, usually in years, hours, or seconds. The rate of change can be found on the first page of your earth science reference tables. If you go there, you will find there is an equation box on your reference tables, and the rate of change equation should be there. So, the formula that you'll find on that first page of your earth science reference tables that you cannot forget is there, because you will need to use this equation throughout the whole entire year. You will see the formula of change in value over change in time. So how much it changed from at one point to another point over how long it took. Okay, so for example, they want to figure out the change in temperature per hour. So I know that in Cambridge at 8 a.m. it was 29 degrees Fahrenheit, and at Cambridge at 12 p.m. it was 45. So change in value over change in time, I would take 45 and subtract 29, however long, and then divide it by however long it took. Well, 8 to noon, 8 to 9, 9 to 10, 10 to 11, 11 to 12. So over 4 hours, it changed to be 16 degrees Fahrenheit for 4 hours, so it was 4 degrees Fahrenheit per hour. Okay, all I did was I took the change in value, divided it by the change in time to figure out how many degrees it changed per hour. So for example, with this one, Salem has a temperature of 53 degrees at 10 a.m. At 3 p.m. the temperature is 62. What is the rate of change? So I'm going to take, I know that it was 53 and 62. So 62 minus 53, and I can't think on my feet right now because it is crazy hot in here. Minus 53, I get 9. So it was a 9-degree change divided by the amount of time it took. Well, it went from 10 a.m. to 3 p.m. So 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3. It took 5 hours. So 9 divided by 5 is 1.8. But what's my unit? What am I measuring? Well, this was degree Fahrenheit, and these were measured in hours. So it would be 1.8 degrees Fahrenheit per hour. Okay, is that what it came out to? 1.8 degrees Fahrenheit per hour. Good. Moving on. Whoop, whoop. In Bennington, Vermont, it has a temperature of 30 degrees Fahrenheit at 4 a.m. and at 1 p.m. the temperature is 63. What is the rate of change? So it's a change in value, 63 minus 30, and we're talking about degrees Fahrenheit here. So this one I can kind of do in my head. So 63 minus 30 is 33 degrees was the change in value over how much time? Well, it said the temperature at 4 a.m. to 1 p.m. Well, 4 to 5, 6, 7, 8, 9, 10, 11, 12, 1. So that is over 9 hours. So 33 divided by 9 gets me 3.6 6 repeating. So if I'm gonna round to the nearest thousand or hundredths or tenths, sorry, degrees Fahrenheit per hour. Check my answer. 3.7 degrees Fahrenheit per hour. Good. Another one. At 11 a.m. in Albany, New York, had a temperature of 68 degrees Fahrenheit, and at 3 p.m. the temperature was 50. What's the rate of change? So I'm going to do 68 minus 50 for my degrees Fahrenheit here. So I get 18 over how much time? Well, it said at 11 a.m. and then to 3 p.m. So it went 11 to 12, 1, 2, 3, so 4 hours. 18 divided by 4.5 degrees Fahrenheit per hour. Notice I'm not just writing degrees, I'm actually specifying degrees Fahrenheit because there are other measurements of temperature that you need to pay attention to sometimes, and specifically this one's degrees Fahrenheit, not Celsius. And there's my answer. I did it right. Sometimes I do make mistakes. Next one, at 9 a.m. in Albany, New York, it had a temperature of 70 degrees Fahrenheit at 11 a.m. and then the temperature was 85 degrees Fahrenheit at 11. So I have to do 85 minus 70. That one's pretty easy. Easy peasy lemon squeezy. 15 degrees Fahrenheit over how much time? So it went from 9 a.m. to 11 a.m. So that was 2 hours. It should be 7.5 degrees Fahrenheit per hour. Did I do it right? It looks like I did. Good job. Now, 11 a.m. in Albany had a barometric, ooh, we've changed it up a little bit. We're not using temperature. We're going to talk about barometric pressure. So it has a barometric pressure of 1,004.5 millibars, and at 6 p.m. the barometric pressure was 1,056.5 millibars. What is the rate of change? So nothing's going to change. It's going to be the change in field value, which is 1,056.5 minus 1,004.5 equals, this is where your handy dandy calculators come into play, minus 1,004.5, I get 52. So there's my millibars. Over how much time? Well, it went from 11 a.m. to 6 p.m. So 11 to 12, 1, 2, 3, 4, 5, 6. So it is 7 hours, millibars. So 52 divided by 7. I did that wrong. You get 7.4 millibars per hour. Hopefully I did it right. It looks like I did, 7.4 millibars per hour. So you can use rate of change for lots of different things. In this case, we used it for temperature over time. We used it for barometric pressure over time. There's lots of different ways that we can use it. And we have another example. So at 11 a.m. on October 11th, a hurricane had a barometric pressure of 996.7 millibars. And at 11 a.m. on October 14th, the barometric pressure was 971.2. What is the rate of change in days? Notice they said days. So if I'm going from 971.2 minus 996.7 millibars, almost wrote that B wrong, 971.2 minus 996.7. Why can I not type in my calculator correct today? It's because Miss Baker, you put it on the board wrong. 996.7 minus 9. Told you I make mistakes sometimes, especially with math, because sometimes my numbers in my head switcheroo, and I usually am able to catch myself There we go. 25.5 millibars over the course of what? Notice we're not measuring it in hours anymore, we're measuring it in days. So if we went from October 11th to October 14th, we are going to go over the course of 12th, 13th, 14th, 3 days. So our answer would be 8.5 days, right here. I don't need to write it down for you. We've done a ton of them now. But you get the point that it can change from hours to days. It all depends on what they ask for in terms of what you're measuring. So, like at 2 minutes, the temperature is 45 degrees Fahrenheit. And at 8 minutes, the temperature is 80 degrees Fahrenheit. What's the rate of change? Well, you would do 80 minus 45 equals, I told you, I have brain farts sometimes, so I'm going to check it. I have 35 over, well, it went from 2 minutes to 8 minutes, so how many minutes is in between there? 6, good. So then 35 divided by 6 is going to be 5.8. And we're talking about temperature, so degrees Fahrenheit per minute. Sorry, that's a funky looking M. Now, we already went over all these questions just now, and that's good. Perfect.